The next hypothesis that we're going to look at is hypothesis about proportions. So in all the previous videos we looked at hypothesis about population mean mu. So now we're going to look at population proportion P when the population contains only two possible outcomes, like male or female, or smoker or non-smoker, and that kind of stuff. So only two possible outcomes, then we have fraction or proportion of population success, that is denoted by pi. Okay, and the sample proportion will be x over n. We have seen this kind of notation before. Number of categories of interest in the sample divided by sample size, the sample proportion of success. Okay, and now for us to be able to use the normal distribution based hypothesis testing procedure, we need to have large sample, because we know that the population is not normal, population is binomial. So for normal distribution based test to work, the sample size must be large enough, and for that n times p and n times 1 minus p must be at least 5, and we can approximate this by using p in this equation and not pi, or we can use the pi value from the hypothesis. Whatever we use in the hypothesis for pi, that's what we will use here. Okay, and mu sub p is pi, and sigma sub p is pi times 1 minus pi over n. In confidence interval calculations, we had to substitute p for pi, but in hypothesis testing that is not necessary, because we do have a value for pi in the hypothesis. So we take the value of pi from the hypothesis and insert it here, and that will give us sigma sub p, and that is a very critical difference. You need to note that. Okay, so then we use z stat, and the rest of the procedure is exactly same as what we have seen before, either a one-tailed test or a two-tailed test. Now this is an equivalent form of the z stat that we saw in the previous slide. Okay, but we don't have to use, we will stick with this formula. So here is an example. Okay, suppose we have a marketing company that claims that it receives 8% responses from its mailing. So to test this claim, a random sample of 500 surveys were sent out with 25 responses coming back. Okay, does that mean that the marketing company's claim that it receives 8% response is true? Well, first to check whether we have large sample, so n times pi, so now we can use the pi value itself, the 8% value. So 500 times 8%, 500 times 1 minus 8% gives you greater than or equal to 5. So large sample checks. Then we want to test whether it is 8% or not 8%. Okay, alpha 5%. So n is 500 and p is 25 over 500. So that gives you 0.05. So plug in the values. Okay, so you get minus 2.47, and for 5% alpha, the two critical values of z is 1.96 and minus 1.96, and minus 2.47 being on the left side rejection region, we reject the null hypothesis. Now if we compute the p-value, the tail area for minus 2.47 and then multiply by 2, because it is a two-tailed test, that will give us the p-value. Okay, so here is the p-value, which is 0.0136. So that is why we reject the null hypothesis.